Now, how does a diesel engine work? Okay, so we know that a diesel engine is a four-stroke engine. We have induction, compression, ignition, and exhaust. So it's the same kind of a cycle as a gasoline engine. But why is a diesel different? What makes it different? So we know it's a workhorse of industry and commerce. So we have more power and more torque, and you see it used for big industrial vehicles more than recreational cars and boats. But what's the difference? So basically, a gasoline engine, we compress air and fuel together in a combustion chamber. We pressurize it and push it up and get the pressure very hot, and then we spray fuel in. And at that point, we ignite with a spark plug. So now you know exactly where that combustion process is going to start, and then it's going to move down and push the piston down where you get your engine turning. In a diesel engine, basically you're going to compress the hot air and gas into a very small space, but there is no spark. So the pressure and temperature alone are enough to auto-combust that fuel-air mixture. And from that, the engine continues to cycle on. As you pressurize more fuel, it combusts and pushes the piston down, and it continues on basically using the energy from that fuel. Now, the engine operates the same way, though, as a gasoline engine. We have induction, where you're pulling in air, external air or atmospheric air, into the combustion chamber. Now, that's also accompanied typically by a turbo for diesels. We want to put as much air as we can into the combustion chamber. Then you have compression. So we're pushing that air up into a very small space inside the combustion chamber, which is increasing the heat of that air. The more you pressurize a gas, the higher the temperature is. And at that point, as it reaches its highest point, we spray fuel into the air, hopefully atomizing that fuel-air mixture, which is then going to ignite. Now, as that ignites, the fuel-air mixture expands outward as that reaction takes place. That's going to push the piston down, and there may be multiple injection events depending on the type of injection system. But basically the goal is to continue that combustion reaction, pushing the piston down and keeping force on that piston throughout its travel. And then as that piston makes its next stroke, it's exhausting all that gas and remaining unburnt fuel or whatever else is not combusted completely into water and carbon dioxide out into your exhaust. And that's kind of where your scrubber system or your catalytic converter or your basically your exhaust system takes over at that point.